People have always told me that C++ is faster than Python, but I want to investigate and see if this is actually true. Let's start with C++. So here we've made a program that uses chrono, that's just going to time us here. And we have a for loop that's going to go all the way up to 1,000, not inclusive to it, starting from 0, and it's going to print out those numbers. So let's see what happens. Okay, so let's compile it. And it didn't even take a second. 0 seconds. Are you kidding me? Okay, let me try this again one more time. Let me increase the number of zeros here. Let's give it a little bit of a task. Let's do 100,000. Why not? Okay. Let's do this one more time. Ooh, I didn't save it. It's going to be an issue. Save that. Zero seconds. Are you kidding me? Still 0 seconds? You know what? Let me turn this into microseconds. Maybe that's why. It's a little too fast. Okay. Save it now. Maybe. Okay, it compiles, a good sign. Huh. Okay. We've got 275,669 microseconds. I'll put up the conversion on the screen right now. All right? Okay. I don't know. I'm pretty sure this is a very, very small number, man. I think Python's going to get absolutely dusted. Let's just add another 0, because why not? And then let's do seconds. I want to see how many zeros it takes to make it into a second. Okay, let's see this. Seconds. Okay, let's do that. That's definitely a second. Okay, so 2 seconds. 2 seconds for what? What is this? This is 1,000,000. Right? This has got to be insane. So to count up to 1,000,000, it basically took 2 seconds. It's pretty incredible. Pretty incredible. Now let's go on to Python. So in Python, we've set up the same exact thing. We've imported time. And yeah, this should basically tell us the amount of time that it took to run. So the first thing that we're basically going to do is we're going to do it for 1,000. All right. So let's do it. Let's run it. So 0.27 seconds, not too bad. Now let's up the scale to 10,000. Takes quite the bit of time, and already 10,000 is somehow similar to C++'s 1,000,000. So now I know for a fact Python is going to get swept. But now let's add another 0. Let's make this 100,000. And this is going to be taking some time.
1 hour later.
Oh, hell no, man.
Okay, so that took 27 seconds for 100,000. It's quite a bit of a difference. And now let's put in what we've all been waiting for, 1,000,000.
One eternity later.
269.904 seconds. It finally hit 1,000,000. Not hit it, but I guess it approached it. So the difference between C++ and Python is quite big in terms of speed, of course. When we try to visualize this data, we can see that at 100,000 iterations, C++ took 0.2765 seconds. Python took 27 seconds. At 1,000,000, C++ took 2 seconds, and Python took 269 seconds. I wanted to know why, so I did some research. Number 1, Python is an interpreted language, while C++ is a compiled language. This basically just means that Python code is executed line by line by the interpreter, right, when it's run. While C++ is a compiled language, where code is turned into machine code before it's actually executed, making it way faster. Number 2, Python uses dynamic typing, while C++ uses static typing. Not this typing. I mean this typing. So, what is dynamic typing in this case? So, this just means that variable types are determined at runtime, right? Here we just put a is equal to 787, while for C++ we actually have to declare that it's going to be an integer. So there I said integer a equals 787. So in this case, this could potentially take more time to do this. Number 3, memory management. Python uses automatic garbage collection, known as GC in short, to manage its memory. This can produce performance overhead, while C++ gives the programmer manual memory management, allowing for better memory usage. But only real programmers know what a segfault does to you. Now, bytecode. Python code is first converted into bytecode, which is then interpreted by the Python virtual machine, right? While C++ code compiles directly into machine code, which executes way faster. And finally, GIL, which is a global interpreter lock. And Python's GIL actually restricts multiple threads from executed Python bytecode simultaneously, and this can limit CPU-bound multithreading, while C++ has a true multithreading, and it can efficiently use multi-core processors. Thank you for watching, and have a great day.